We are building the Fractals and Recursion program from the YByte Python curriculum available at www.ybyte.in. We just saw how we could create a simple recursion, square calling itself, and we get this pattern. Now, in order to understand recursion better, I'm going to make a small little twist on this function, and you will see the outcome is quite interesting, similar yet different. So what I'm going to do is that I'm going to say, okay, look, now instead of calling the recursive call at the end, I will call it, let's say, at the very beginning. Now this is very, very interesting. So basically I'm saying that, look, previously I was drawing the square first and then checking if I want to make a recursive call and making it. Now I'm saying that, okay, look, let me first make the recursive call and then go and draw. Now, this is really very, interesting from a point of view of understanding how this recursive flows work. When I do this, for example, notice again, I have my turtle waiting at 0, 0. I am going to give the same exact command, but see carefully what happens. In fact, the turtle ends up with the same outcome in the end, but if you saw carefully, you will realize square, let's say 5 got drawn the first, then square 4, then square 3, then square 2, and finally square 1. Now this is exactly the reverse order. Previously in the original order, we had square 1 being drawn, then square 2, then square 3, square 4, and square 5. Let us try to analyze what happened in this case, because like I said, this gives us a good picture of how recursive code actually works. Basically, the modification that I've done is that, look, previously I was drawing the square first and then calling a recursive call. Here I'm saying, let me do the recursive call before I draw the function. Now, again, let's go through the sequence as it happens. Now, I give from command line, let's say 0, 0, 100. Now, this is a command that I make. Subsequently, every command is recursive. Every call is recursive. So the function is calling itself. I say 0, 0, 100. Remember the first piece of code. As always, recursive code also runs the same way, top to bottom. The first thing that I encounter is L more than 10. Yes, indeed it is. So I just go and make a recursive call. Now, once that happens, that function does the same thing. It again makes a recursive call until I come to a point where I have L less than 10. Now at that point, remember I'm inside this function here, which means that I'll end up drawing square number 5. Then I'll come out and draw square number 4, come out and draw square number 3, come out and draw square number 2, and then eventually I will draw square number 1, and which is why this whole thing is inverted. Think through this, it's very, very interesting. Now let's try to visualize it one more way. Remember, square 0, 0, 100 is the command that I'm giving from the command line. The function, as we know, runs from top to bottom. So the first statement that I encounter in this function now is, well, look, if L is more than 10, go and call, let's say, square x plus L, y plus L, and L by 2, which means that I end up calling square 100, 150. Now, even though this is a recursive call, the function is still going to run from top to bottom. And hence the first thing I encounter is, well, make another recursive call, this time 150, 150, 25, another recursive call, 175, 175, 12.5, which leads to another recursive call, 187.5, 187.5, and 6.25. Notice that in all this process, not a single square has yet been drawn, because we're just basically getting deeper and deeper into the recursion hierarchy. At this point, however, L is no longer more than 10, which means I do not make a recursive call. So I get out of this if condition. I draw the code, I run the code which basically draws the square number 5. And that's why square number 5 gets drawn the first. This code gets over. I come back to this function. Basically this if condition has gotten over. I come back and draw square number 4. I go back to this point. Again, it means that this condition, if condition has gotten over, I come back and draw square number 3, square number 2, and square number 1. So the whole process happens in a inverted order, as we saw. It's kind of like, we are getting deeper and deeper into the, let's say recursion, and then building it up from bottom up. And this is really interesting to think about. In one case, I kind of built from top to bottom. In the other case, which is now, I have done from bottom to top. So I first go deep, deep, deep down. Start building from that point. Now again, think through this carefully, because this is really telling you some interesting points about recursion. Number one, that recursive function calls are really no different from the original function call. They run the same way. The entire code is run from top to bottom. The only difference is coming that these calls are happening sort of by themselves. The function is doing sort of like, the job which we usually do from, let's say, command line. So they're not explicitly calling them, as part of the runtime, but they're just happening because the function has been defined in that manner. Also, notice the importance of the base condition. If I did not have this, then this process would have just continued. If I did not have this, let's say, if condition, this process would have continued. We won't see anything on the screen, but soon we will run out of the recursion depth. And that's why the base case is very important. Again, try to visualize this. Do not rush through this. Think through very carefully what's going on. Think about why the squares are getting drawn in the inverted order, why they're getting drawn at the place where they're getting drawn, because these thoughts will help you as we go further and do, let's say, more recursion. I hope this was interesting. As I said, in the Why Byte Python curriculum, this is how we learn programming, by building things, analyzing them in detail, and learning our lessons from them. Look at our website, www.whybyte.in, because that is how we learn Python programming. Take care. Thank you so much. Bye-bye.